Hi there. I am inside of a Jupyter notebook, and I have a chart open over here with some temperature data. It's from a dataset that's a subset of something I found on Kaggle. And what you're looking at here are temperature readings for the state of Maine in the United States over time. So in this dataset, we're starting in 1981, and we have data up until about 1990. So one thing you might be interested in using a data set like this is to make a prediction. Maybe we want to predict the temperature. And we can do that in many different ways, but one thing we might primarily be interested in is to model this sort of seasonal aspect that you see over here. There's definitely something of a periodicity at play, and if we can just estimate that, well, then we are well on our way to predict the temperature. Now, I'm using temperature here as a motivating example, but I hope you also recognize that this phenomenon is something that you might have in many different time series tasks. There's usually a seasonal component, and being able to filter that out is a useful act. Turns out, though, that there is actually a very nice feature inside of scikit-learn that will help you with this. So what I would like to do now is I would like to start modeling this in a naive way, just so we can discuss ways to improve, and we're going to work towards a periodic featureizer. Now, before diving into the main trick I would like to explain, let's start off with a relatively simple baseline first. So what I'm doing here is I'm, again, loading this temperature data that you see below. And I'm starting out by just adding some time series features, so to say. So the data frame goes in. I definitely have a timestamp in there. I'm turning that into a proper pandas timestamp type. And then what I'm doing is, from this timestamp column, I am calculating the month, and I am calculating the day of the year, and I'm using that timestamp that I calculated earlier. And just to give you an impression of what that looks like, if I look at the data frame now, after passing this add time features function, we can see that there's a timestamp, the temperature we want to predict, but there's also a month now and a day of the year. Now, in terms of modeling, and this is somewhat basic, but one thing we could do as a base idea is we could just take this month and say, well, let's one-hot encode this, and that way we will have a model where the input of the model, we have month 1, month 2, month 3, etc. And we're just going to say, if it's the first month, we're going to put a 1 here, and in all other situations, we're going to put a 0 here. And by doing this, you will have these one-hot encoded variables, so to say, but this can be valid input for a model that follows. We can pass that to a linear regression. And what I've just described is what's happening in this pipeline you see here. What I'm doing is I'm saying, well, let's first select the month column. I'm using the select calls object from Scrub to do that. That column will then be passed to this one-hot encoder that's going to make this matrix with 1s and 0s. And then those features are going to be passed to a linear regression model. That's what this pipeline is all about. And if I were to run this, what I'm doing here is I'm using that pipeline, I'm fitting it, and I'm making a prediction, but I'm also plotting those predictions. Then you can see that it kind of looks like this. Now, again, this is just a base model that I'm going to use for a motivating example. But one thing I do want to point out is that this does already kind of work. Even though the jumps that we're making are kind of jagged, we can see that it is able to capture a very nice periodic pattern here. But one thing that I always like to do is I always like to look at a base model, and I like to reflect on what doesn't really work so well about it, because that will typically give me a hint on how to make an improvement. Now, in this particular case, the one thing I think I don't like as much is the fact that there is this jagged jump over here. And this is mainly because when you reflect on what's happening in reality, it's not like the temperature changes from December 30th to January 1st. It's not like one day of difference should cause a jump like this. It's just that the features that I have can really only stop and start at the beginning or an end of a month. So if I were to rethink this just a little bit, let's say that this is time. Then right now, the way the features kind of work is that it's 1 month, so then there's one feature jumps up, and then it's another month, and then one feature, or one column, I should say, will have zeros again. And let me pick a different color. But then another month would take its place, and that will be the feature that's active. And you can kind of see that as time moves on, either this feature or this feature is active. It's definitely like a 1 or a 0 kind of a situation. But maybe we can also choose to smooth that out. So if I were to reimagine that for a bit, what if this monthly feature is kind of more like a hill that goes up and then also kind of goes down again? And then the next month would have a peak that's somewhat later. Then in this case, we would have a soft transition from one hill to the next one. And there's kind of two benefits to that. One is you are going to get something of a more smooth prediction over here, which I do think is possibly beneficial. But another thing that's just kind of nice is that this green hill can actually maybe learn from just a little bit more data. If we think about all the data points that that green hill has access to, it'll be across a span that overlaps as well. And something about that also feels very appealing to me, because in the situation over here, a single data point can really only influence either the green hill or the orange one, whereas in this situation over here, a single data point can easily influence 2 or 3 of these hills, and that certainly sounds appealing as well. So, the next question is, how do we generate these features? And for that, we get to talk about the SplineTransformer inside of scikit-learn. So, here's an example of the SplineTransformer. The SplineTransformer is something that you'll be able to find in the pre-processing module inside of scikit-learn. And what we'll be exploring now is what it looks like when you set the extrapolation setting to periodic. As the name implies, this is going to generate features for us that are periodic. But let's just play around with this to get a bit of a feel. So there's a couple of settings. I'll explain those in a bit. But this transformer over here, I'm giving that some input data. In this case, I'm giving it an array of numbers that goes from 1 to 365. This represents the days in the year. But when I just run this, this array is being translated into this multi-dimensional array. So there's these separate columns, you could definitely say. And this is kind of the familiar transformer thing in scikit-learn, where something goes into the transformer and something is definitely going out. Now, the easiest way to give a bit more context onto what these columns actually mean is to actually maybe plot them. So I have matplotlib loaded. So let's run this. And the way to interpret this is that every column you saw in the array before is now a line that's being drawn. So this blue line over here, I think, is the first column. This orange line, I think, is the second one, etc. But you can definitely see there's a line going up and down, and eventually it's going back up again. Let's now play around with the parameters over here. So one thing that I could do is I could change the number of knots. I could say, well, let's not go for 5, let's go for 10. In layman's terms, what that effectively does is it just makes sure that there are more hills that are being generated. These hills are still spread over the entire spectrum of days, you could say. But for a gut feeling at least, this parameter allows you to have thinner hills and more of them. Another thing you could do is you could say, well, I don't want a second degree polynomial spline, I want a first degree one. And then you just get this straight line that sort of goes up to a peak and immediately goes straight down again. So in a way, you could see this degree as kind of a smoothing parameter or like a peakiness parameter for each hill. And there's definitely some subtle details here, but in my experience at least, this does change the shape of the hill in question, but you're really going to notice a difference if you're only setting a degree equal to 1, mainly because it really gets spiky. But a second degree or a third degree gives you this nice smooth curve. Now, there's a final setting that I just want to mention, but it's not going to be extremely relevant to what we're going to be doing. But there's also the matter of how do you place the hill on the spectrum that you have. Because right now, we have spaced them evenly. You can see that there's a distance between each hill, and it's the same distance everywhere. But maybe you want to have just slightly more hills in an area where there's just more data. So one thing that you could also do is you could say, well, to handle that, I would like to have these places of these hills, these knots, be determined by the quantile of the data that goes in. It's just that, in my case, I have a pretty evenly distributed data set over here because each day only appears once. So in this particular use case, this is not going to matter a whole lot. But you could imagine scenarios where you have more data in certain parts of the year or something like that, where this might actually make a bit of a difference. Having said all of this, the main thing that's interesting is that once we train on a span of days, let's say, that we're interested in, We can also project this forward. And that's what I'm doing in the code block below here. I am generating a longer sequence of days. So you can see I'm definitely generating a longer period over here. And I'm using the same transformer that I just declared. I'm just passing it this longer array. And you can now see that this orange peak over here, if I were just to draw over it, it goes down over here, but then at some point it definitely goes back up again. And this is the repeating phenomenon at play. And if we assume that the x-axis is the number of days in the year, then we can definitely see something go up and down, and that's going to repeat every single year. So instead of having these jagged, one-hot encoded variables that really just go up and down immediately, this might be a set of features that we can pass to a linear regressor or what have you model, and we're able to get a smooth representation for a seasonal effect. And just to demo that, what I could do is I could make a new pipeline. In this case, I'm giving it the day of the year. That is being passed to this SplineTransformer. That's being followed up by a linear regression. So it's pretty much the same thing, except that I'm now dealing with these smooth values instead of this month value that I showed earlier. And if I were now to show you what the predictions look like here, then lo and behold, the prediction actually represents kind of a nice, smooth curve. But we can play around with this a little bit if we'd like. So let's go back up and change the hyperparameters just a little bit. So let's now set the number of knots here to something that's quite high, like 100, let's say. Well, if we do that, we notice it actually gets kind of jiggly. And it also makes sense, because we're making lots of thin hills over here. The hills are super small and spiky, but they do properly repeat. You can see this minor tick happen every single year at the same spot. We can also set the knots to maybe somewhere in the middle, let's say 20. And you would have to do proper grid search in order to know for sure, but this looks pretty reasonable in a way.
But also if I think a little bit more about the interpretation, 20 knots, that's about a hill every 2 weeks or so. Not exactly, but it kind of feels plausible that that might be useful for this particular data set as well. Maybe we need a little bit more hills than one for each month. On one end of the spectrum, you kind of had the perfect sine wave, which might not be the best representation of the actual season. But this is also not as jagged as the super thin peaks we saw earlier. So you could argue this is a little bit more balanced, and that's kind of nice. Hopefully you can also feel that there is a overfitting phenomenon that could be taking place here. So again, if you're going to be building actual models with this, do make sure you run your proper grid search. But maybe here is also a pretty good place to end, because yeah, that SplineTransformer with that periodic setting is actually very nice and convenient when you're trying to do some of these time series tasks where there's a seasonal pattern that you would like to pick up. One thing I do want to mention is that even though I do think this is a very nice technique, time series, of course, are more than just a seasonal pattern. There's typically also stuff like a long-term trend and a short-term correction. And if you're dealing with sales, you also want to think about days in the week and maybe even holidays. But again, as a technique, I do think that this SplineTransformer is just very nice and useful, and it's a very nice feature that you can actually use from scikit-learn.